Last week we started using SQL a little bit. I introduced you to some of the commands we needed to create our schema, right? So to build our database, we had to use some commands to create our tables. We had to use some commands to insert some data. And this week I'm going to talk about those commands in a little bit more formally, kind of just a review of some of those DDL commands. But really this week is to introduce you to DML, which is how we can manipulate our data and work with our data and look at our data. So really how we start doing analysis of our data, right? So we're going to start talking about that this week, and then in the next video after this one, there'll be a video that gets in a little bit more detail on things like doing joins for selecting from multiple tables, and I'll also talk about doing aggregate functions and things like that, what those look like, and of course we'll review what triggers and stored procedures are, but I'm not going to ask you to write those in this course. So let's get started. Let's talk about SQL. I just want to give you a little bit of background about SQL, where it came from, why we use it. It's kind of important to understand, some of the standardization behind the structured query language. Of course, it stands for structured query language, right? Most of us pronounce it SQL, like the sequel to a movie. So it's the standard for relational database management systems. And I would argue it's the standard even beyond relational. We see the SQL syntax used in many databases that aren't even relational databases. So you see them in other, and of course they have their own languages as well, but a lot of times you can use SQL because people are so familiar with SQL. It's so pervasive in the industry that a lot of people, a lot of folks want to use it in other platforms as well. So an RDBMS, as I discussed before, this is the database management system that manages our data, right? It's our collection of tables. It's all of the relationships that are in that schema that we created last week, right? So that's our RDBMS. And again, that's what's going to run SQL. I'll talk a bit more about the SQL environment here in just a minute, but a little bit of history about SQL. So if you go back to 1970, E.F. Cobb developed the relational database concept back in 1970. Before that, we had other database concepts. There were flat files, of course, hierarchical data management systems, which are still in use today, some of those systems. But E.F. Cobb developed relational database concept. And of course, the interesting thing about the relational concept was data integrity. Relational has a higher degree of data integrity than many of the other models did at the time. So from 1974 to 79, System R, which with SQL, which was later SQL, was developed at IBM Research Lab. R is still used today for statistical analysis. You'll hear about R in probably other classes. Maybe if you learn a little bit about data science or something like that. In 1979, Oracle marketed the first relational database with SQL, right? So 1970, E.F. Cobb develops the concept. In 1979, Oracle makes it a reality. And to this day, Oracle is probably one of the largest database companies, right? Relational database. They have probably one of the most common relational database management systems on the planet with their Oracle platform. And we use SQL to interact with Oracle. 1981, SQL DS is first available on DOS and VSE. Others followed, like Ingress, IDM, SGL, Sybase in 1986. Sybase, for those of you who don't know, is the precursor to Microsoft SQL Server. So Microsoft SQL Server was Sybase. Sybase was forked. Microsoft bought the source code and forked. One version became Microsoft SQL Server. Sybase is still in existence. They have their own version. And there was a couple other ones that came out around that time too, and are missing on that list from our textbook. By the way, that list is from your textbook. And then in 1986, ANSI, which is a standards organization, developed a standard around SQL. They said, okay, we've got all these different database management systems that are on the market now that use SQL. So that should be standardized. So whether you're using Sybase or Oracle or IBM's platform, right? It didn't matter. You wanted to have the same syntax to use SQL, just like programming languages had syntax. ANSI standardized things like the syntax for C and C++ later in other languages. So somewhat the same thing happened here. ANSI developed a standard around SQL, around the SQL that Oracle created, right? So the major answer standard updates were from 1989, 92, 99, 2003, 6, 8, 11, and 16. I don't think after 2016, I think ANSI stopped publishing a standard for SQL. So that would be the last one I think that's standardized from ANSI. But there are other organizations that standardize that. So SQL is supported by almost every major database. Almost actually all of the relational database management systems support SQL. Not every database does SQL, right? So, for example, some of you may have taken a class on Active Directory or LDAP, right? In the Linux world, maybe you learned about LDAP. In Windows, you learned about Active Directory, the most common network operating system on the planet. I would argue that there's probably more installations of an Active Directory database than Oracle, right? Because you know Oracle's not in every company, but Active Directory is. Every Windows server probably has some derivative of Active Directory, and that is a database, but it doesn't support SQL, right? So it's not in every database. There's certainly databases that exist that don't use SQL, which we're learning about in this class, but I would say the vast majority of the ones that we use for data management uh, typically use SQL. But you would have to learn other query languages to interact with some of these other database engines like LDAP and Active Directory. They use their own query language, right? LDIF is the language you use with AD and LDAP, and then there's other languages for other hierarchical-based database management systems that are out there that are not relational. So like I said today, SQL, is it really still a standard? It's no longer certified by NIST, but ANSI still has these standards that exist. So that's an interesting discussion question. So the original purpose of the SQL standard was first to specify the syntax and semantics for data definition and manipulation, right? So that's DDL and DML, data definition language, data manipulation language. So what is the syntax and the semantics so they're common across all platforms? We wanted to define data structures and basic operations. What can we do with this language? Enable portability of database definition and application modules so that we could, and what we mean by portability is you can apply it to just about any database management system. Specify minimal level 1 and complete level 2 standards. Allow for later growth and enhancement to the standard, such as referential integrity, transaction management, user-defined functions, join operations, international character sets, right? So adding that additional functionality. And of course, the standard has grown a bit since 1986, right? A lot of new functionality was added in many of the database engines, and since a lot of them had common functionality, it was extended in the standard to support some of that stuff. So some of the benefits of having a standardized relational language is reducing training costs, because if you're in this class learning SQL, and you probably learned some SQL in a previous course as well, and you can apply this, and you probably see, that previous class you took was probably in Oracle, right? In this class, we're using MariaDB to teach the same concepts, but they're a completely different platform, right? But it's the same language. Now you could argue that MariaDB has its roots in Oracle, right? Because it's from MySQL. MySQL is now owned by Oracle, but MySQL was originally developed completely separate from Oracle. They were not the same developers. It wasn't the same company. Oracle purchased the company that owned MySQL at some point, so it kind of became part of the Oracle family. But to that end, I could just as easily be teaching you Microsoft SQL Server, and it would be basically the same as learning SQL for Oracle for the most part. There are some minor differences between different database engines. In fact, you'll notice that in your textbook, some of the examples are not going to work in MariaDB. You have to modify them just a little bit. So my examples are going to use MariaDB when I show you. So there's two videos. There's the video that is the lecture that you're watching now, but I also have a lab video where I introduce you to some of the syntax, using MariaDB, so you can see what that looks like and how it differs a little bit from the book. Certainly increases productivity. Applications can use just about any database engine if you do it right. And it's the neat thing. There's lots of libraries out there for these different software development, and programming languages that allow you to forklift your application from one database engine to another. In fact, many vendors, when you purchase their software, you have a choice. You can tell them, when you're installing their software, are you going to use Oracle, Microsoft, MySQL, and so forth. You can pick which database engine you want to use. So it decouples the application from being bound to a specific database engine, which is pretty valuable. And one of the reasons that's valuable, by the way, for a DBA, this is great, because if you've chosen a certain database platform for your organization, it's nice if everyone can use that platform, right? I work with a lot of companies that have adopted one of these major database vendors as their platform. And then a vendor comes along and says, oh, we don't support Oracle. We only support Microsoft. So then they have to, build a Microsoft environment to support all the Microsoft people, right? So now you have two different database engines that you have to manage. Not only that, but there's a disconnect between the data in these two different platforms, right? You have to do a little bit of work to get these two different platforms to talk to each other, and to have data available across the wider organization. It creates some interesting challenges, but and most people solve these challenges, right? It's the environment that most of us live in. But it sure is kind of neat if you can have an organization that only needs one of these platforms. But invariably, once you pick one, somebody's going to come along and say, "Oh, we don't support that one," right? So certainly good for portability and longevity. Reduced dependence on a single vendor, as I just described. Cross-system communication again, which I just described, right? So those are some of the benefits of having standardized relational language, right? All these different systems can talk to each other using SQL. They can talk to each other's databases, right? So lots of neat things about having this standardized relational language. Our SQL environment, regardless of which database engine you're using, typically you'll have a catalog, excuse me, which is a set of schemas that describe the database. A schema is the structure of objects within that database. These are going to be your views, your constraints, your tables. We've already built tables. We're going to learn about views next week. I'll talk more about what those are. And again, in constraints, we'll talk a little about those later as well. And then you have your three ways of working with the database. You have data definition language, which is the commands to define the database, building tables, dropping tables, indexes, and all that sort of thing. You have your data manipulation language, which is how you actually work with the database. It's how you put new data in, get data out, and change data, right? Modify your data. And then finally, DCL, or data control language, which is the commands to control a database. And we're going to learn more about DCL later on. And it's going to kind of spill over into the follow-on to this course. So in the follow-on to this course, we learn a lot more on DCL, kind of lay the groundwork here in the first course, with the database itself, and then we'll learn more about managing that database with DCL. Of course, we'll do some of that here in this class as well. So you start with your DBMS. Your DBMS, as far as the components, you have a catalog, which we talked about. And within that catalog, you've got your actual data, right? That's your raw data that's on disk, organized into relations or tables. And then you have your schemas, right? So you have your required information schema and then your user schemas. You'll probably have several of those catalogs, right? Different databases, all managed under the same database management system. So in this case, I've got two different instances of databases with their own schemas in each side. They could be the same schemas because we're replicating and with a distributed environment. We'll talk more about that in the follow-on course as well. And then you have your applications. Applications are what's used by our users. So users are using applications, which are then connecting to DBMS to get information from our two, in this case, our two databases, right? It doesn't just have to be two. It could be many more. It could be just one. But that's the basic layout of a SQL environment. And this is as described in the SQL 2016 standard. You'll see a similar drawing in that standard. So as far as data definition, manipulation, and control languages, how do they affect physical design, implementation, and maintenance? So DDL is used during physical design and maintenance, right? So we're in physical design, we're creating our tables, we're creating our schema, and then over time we're maintaining that by making changes to the database. With DML, this is how we implement our database and maintain it over time, right? So we're, bringing all of our new data in like we did in Lab 4. Then we're manipulating that data over time. We're working with that data, adding new, data over time and so forth. And then finally, data control language is also used during the implementation and maintenance phase. So that's when we're using DDL, DML, and DCL. So data definition languages, we already learned data definition language in the previous unit. We sort of learned it by doing it, right? We did it with those labs. You kind of saw what that looked like. I showed you some examples in the lecture video, in the previous lecture video. So we use create schema to create our schema or create our database, depending on how it works in your database engine. For MariaDB, we use create schema, but create table also, or create database also worked. Then we created our tables. We could create views later on. We're going to learn about that again later on. And there are other create statements like create character set, collation, translation, assertion, domain, right? We're going to learn about those, I think, more in the follow-on to this course. So we're going to kind of start simple here. So in order to create a table, if you recall from last week, first we identified the data types for all the attributes. In our, we created our diagram. We identified the what all the data types were for the attributes. Then we identified the columns that can and cannot be null. We figured out which ones we can leave null. We identified columns that have to be unique, which were our keys. We identified our primary key and then our foreign key mates, right? We figured out what are the foreign keys, added them if we needed to in our diagrams. We maybe brainstormed on default values. We didn't really do that in our diagram, but we didn't need to. But we might need some default values. Identify any constraints. Domain specifications, right? So constraints are what's allowed in a certain field or a certain column. And then we create the table with any associated index. That was the last step. We created that create statement, which I asked you about in the midterm exam. So the syntax for create table, this is the full syntax. You create table and then table name is a variable, right? The column definition with its constraint, and you list all these different columns, and the constraints can be on commit, delete, preserve, and so forth and so on. So there's a lot of stuff in here. For the most part, we stopped on the second line, right? We created our table, with things like a primary key, but that was and foreign keys, but that's about it. That's where we stopped. But there's a lot more that you can do according to SQL 99. And some of this is not supported in MariaDB, right? So just because the standard defines this stuff doesn't necessarily mean that it's supported in the database engine. So sometimes you have to be a little bit pragmatic about the standard and the specific database engine that you're using. So let's continue on. I showed you an example similar to this in the previous lecture where we looked at a database diagram and then we created our create table statements. This is from your textbook, Modern Database Management, right? This is from our textbook, and it's a little bit different than the syntax we use in MariaDB, right? So some of this wouldn't work in MariaDB. A lot of it will, but some of it won't. For example, in MariaDB, you don't say constraint before your primary key, right? In some versions it works because they try to support what's in SQL 99, but it may not necessarily work, right? It's a slightly different different syntax. And also, in MariaDB we do primary key and then we put the table name and then parenthetically the column name, right? So again, it's a little different, the syntax, than what's in your book. Same with the foreign keys, right? In your textbook, you add a constraint for the foreign key according to SQL 99, but in our database engine in MariaDB, you just put references right in the line with the column that you're creating and the reference to the table. So it's similar syntax, but I don't know that a constraint will work in MariaDB. It may work. Some of this stuff will work both ways, right? So some things are compatible with SQL 99 or SQL 2016 in this case, and some things aren't. So certainly you could try it. Here's another example, right? So here we have all of our column names, and then there's a check constraint in here. And again, I don't know that the check constraint in this syntax would work in MariaDB. You can certainly try it, but MariaDB doesn't really have the same. Oracle's got a lot more functionality with this type of stuff than I think MariaDB does. Same with Microsoft SQL Server. They may have more functionality with things like referential integrity and so forth. And also it depends on the database engine, that you select for MariaDB, right? So MariaDB supported those 5 database engines. The top 3 were InnoDB, MyISAM, and ARIA. And I think ARIA supports, ARIA and MyISAM both support referential integrity to some extent, but it's not, again, not as good, I think, as you might find in some of the other database engines. Again, we already covered this, so I don't want to spend a lot of time going over DDL. But a part of DDL is data integrity controls, like validating and ensuring referential integrity through foreign key constraints. As I said, in this course, we're using MariaDB as our example, and in the database engine, we used InnoDB for our database that we created previously, so it's not going to enforce that referential integrity. But as I said, we could have chosen a database engine that does, right? We could have used MyISAM or ARIA and have it enforce that referential integrity. But if you have that referential integrity, it's going to restrict the deletion of primary records. The updates of primary records, insertions of dependent records, right? All of that's going to be dependent on the primary and foreign key relationships, and depending on how you configure it as well, right? So sometimes there's the cascading functionality that some database engines have, where you can cascade deletes and updates based on changes to subordinate records, or the other way around. So referential integrity is enforced via the primary to foreign key match, right? Which we sort of saw that. This is the example from your textbook, right? Where customer ID is the foreign key in the order table. Remember, our foreign key is always on the many side of the relationship, right? So we shouldn't be able to insert an order with a customer ID for a customer that doesn't exist. And likewise, we can't delete a customer if they have orders, right? That's the general idea with referential integrity. So I can't create an order without a customer, and I can't delete a customer if they have an order. And again, you could control some of that, right? So in some systems, you might say, well, I do want to be able to have the ability to remove a customer that has orders. If they haven't ordered anything in 10 years, just remove them, but I'm still keeping the order files around in case I need to do some analytics, right? So in theory, you could do that. We do that sometimes in healthcare where the patient records are gone, but we still have a record that we administered medication to somebody 5 years ago or 10 years ago or something like that, right? Which, kind of from that example, we did our EMAR example in one of our labs. You can think that, in that example, if you created a patient table, does the patient record have to control the administration of medication? Or if I delete a patient and they have records of medication being administered, right, is that going to be a problem? So these are design decisions, more or less. DDL also supports making changes to the database, such as the alter table statement, which allows you to change column specifications. So we can make changes with the alter. We can make changes to a table. We can add additional columns. We can drop columns that we no longer need. So we can make some changes. We could change we can add additional columns, right? For, in this case, we're altering the customer table and we're adding the column customer type. It's got a varchar 2 data type, 10's the maximum length, and the default value is going to be commercial, right? All of those could be the same, right? If we're altering the table and we're adding a column, we could also alter a column to make it the same, except maybe we're just adding a default value, right? We forgot to do that, so we add it, right? So we can use SQL to do that. It's important to note that you can also do a lot of this in the UIs, right? So we installed SQL Yog, and we also installed MySQL Workbench for this course to manage MariaDB. And with both of those tools, a lot of this stuff you can do from the GUI as well. As a DBA, you want to know how to do this at the command line. You want to know how to do this with the actual SQL commands. You have a lot more granular control when you do it with the SQL commands. Also, in some cases, you have to modify SQL scripts and things like that. So it's really good to know the SQL commands for all of this stuff, and not get stuck just using the GUI all the time, right? You might have to force yourself to do this with the command line to really learn them well, but it's good that you can get to the point where you can sort of just write these off the cuff without having to look up the syntax. And a lot of DBAs can do that. I would say most DBAs can write these commands without using the GUI if they need to, but a lot of them, a lot of us use the GUI when it's easier. You can remove tables with the drop table command. We haven't done that yet in our labs, but we could if we wanted to, right? We could drop a table. You can drop a database or a schema. You can, remove columns and things like that. So once we have DDL squared away, then we can start using DML. And we did a little bit of DML, right? I showed you how to construct insert statements for your databases last week. And I also showed you how to do a simple select statement. And we'll kind of extend that a little bit this week. We'll do a little bit more, we'll do some more work with the select statements this week as we continue our introduction to SQL Server. I'm sorry, to the SQL language. So the insert statement is going to add additional columns, right? Here's an example of an insert statement. So this just inserts values into all of the columns for the customer underscore T table. Note that there's no list of column names here, right? So if you don't list the column names first, so you've got that values keyword in front of values, parenthetically you can list the column names, but here it's not done because we're inserting all the columns. It's redundant to do that. We're just listing all the values because every column is going to have a value and we've got them in the right order, right? We know what order they're defined in the schema. so we can make our insert follow that same order. Now, if we didn't know the order of the columns, or if we didn't want to insert something to all of the columns, we can list the columns we want to insert a value into, and then what those values are. Anything that we did not list in the column list, right? So here we listed product ID, product description, finish, and standard price. If we didn't list any of this stuff, right, there's columns that are missing here, it's simply going to leave them null in the database. They're going to be null. They're going to have nothing, right? They're not going to exist, those columns. And later on, we can certainly add values into those columns with update statements. You can also create you can insert to a table from another table. So you can insert into one table by selecting data from another table, as long as it matches your list of column names. So instead of just saying insert into CA customer T, I could list specifically the columns that I want to insert into this new table, right? I'm sorry, into the select star. And we'll learn more about select in a few minutes. But basically what this is going to do, I just want to make this clear, that this statement is going to create the CA customer underscore T table, right? So this is actually going to create a new table called CA customer T. And that new table by default is going to have all the data from that query that we use. So in this case, we're creating a California customer table, and we're doing that from selecting all of our California customers with a select statement. And again, we could have defined the specific columns we want in this new table instead of all the columns. But when you do this, it's the schema for that new table is going to match the column definitions from the old table. So if one of the columns was a varchar 64, the new column is also going to be a varchar 64. Now, if you want to explicitly create that table first and then do an insert into it, you could also do that. It's a slightly different syntax, but that also works. So a lot of times we're doing that as well. So identity columns. So if we created, if we're inserting data with identity columns, right? So that means, what is an identity column? It's basically a column that we're creating a primary key every time data is inserted, right? So rather than defining what the primary key is when we insert records, or having to know some value that we're going to use for the primary key, instead, we're letting the database create one for us. And usually it's just auto increment, right? It's an integer starting at 1, and we just keep incrementing it up and up and up and up. And I've seen some databases where, they'll keep incrementing that integer, and when they get to the end of that data type, for example, an integer can only go up to, I think, 2 billion rather, right? By default, the size of an integer is up to 2 billion. So when you get to 2 billion, you can go circle back and start with the negative numbers, right? Because integer also supports negative numbers. You can do signed integers, so you can start going backwards, which means you can have the 4 billion records in that table, something like that. But in any event, you're auto incrementing that, so we just don't insert it, right? In this case, we don't have that. We don't need to list that in our values that we're inserting. The database knows that that's an auto increment field, and we're not specifically inserting it. In fact, there are some database engines in here. You see a way to create that. And by the way, this syntax may not work in MariaDB. You can't. It doesn't have as many features as far as increment, so this may not work. But certainly we could look up the syntax there. You may be able to do some interesting things with the auto increment in MariaDB. But in any event, some database engines, they won't even allow you to insert a value. So if you have an identity field, right, a field that's an auto incrementing primary key, like you saw in the database that we created in the previous unit, some database engines won't even let you put a value in. You have to put yourself into a special mode first for allowing identity insert, and then you can do those identity inserts, and then you switch back. That way, otherwise it'll throw an error. So, something to be aware of when you're working with these identity fields. We can delete data, right? So we insert our delete. We may need to delete the data. The syntax is delete from table name, where some parameters. By the way, if you leave off the where clause in a delete, it's going to delete everything, right? So if we just type delete from customer T, it's going to remove all of the rows. And I've done this before by mistake, right? I've typed the delete statement and I forgot to put a where clause, and then you hit execute and you just accidentally deleted everything in a table, right? One of the nice things about using Workbench, right, MySQL Workbench and SQL Yoke, they both do this, is by default they're in what they call safe mode, right? It's not like safe mode for your computer. It's safe mode in the sense that it detects when you're running a query that typically should have a where clause. So whenever you do an update or a delete, if you're missing a where clause, it won't let you do it. You have to go and take yourself out of safe mode, run that query, and then best practice is to put yourself back into safe mode. That way someone doesn't accidentally run a statement without a where clause again, right? So it's important to make sure you remember that where clause when you're working with production data. An update is how we make changes to our data, right? So with an update, for example, I could update my product table and set the standard price to $775 where the product ID is 7. So I'm taking a specific product and I'm updating its price, right? And it's relatively simple, right? You have the update statement and the where clause. You can also do joins and things with this, but we're going to talk more about joins in the next unit. I'm going to get into more detail on how that works. So as far as schema definition, we can also set up indexes. I talked a little bit about indexes, I think, previously, but basically an index, it's sort of like the index in your textbook, right? It's a list of words in a place that's easy to look them up so you can go and find the real location of that particular topic. I think before I explained it using the example of a library, right? And a card catalog. It's a similar concept. But that's one of the choices we have to make when we're creating our databases, and certainly when we maintain them over time, we're adding additional indexes where we find them necessary based on how the data is being used, right? So we're examining how people are using our database, and then we're creating additional indexes if there are things that people are using that that would make sense to have an index, right? How would this manifest itself? Somebody might come up to you and say that the database is running extremely slow when using certain reports or using certain forms. And then you'll realize, oh, this form, everyone is doing a lookup based on the customer's date of birth or something like that, right? And that's not a field that was ever indexed. So you add an index and you've instantly increased the speed of the database for your users. And again, it comes with a little analysis of knowing how people use it. But we also have to maintain those indexes over time. And we're going to talk a little bit more about maintaining indexes and reorganizing and rebuilding indexes in the follow-on to this course. So again, a little bit more detail on that in 366. But for right now, just understand that we have these indexes and we have to maintain those and use those. So I have a whole section here in the slide deck for select statements, and there's a lot of things you could do with select statements. This is probably the vast majority of what we're doing with our databases. We're looking at our data, right? We're analyzing our data. We get the data in. We might update that data periodically, but with a transaction processing system, it's mostly inserts and updates. But then when we're using information in the database, a lot of times that's going to be our select statements. It's how we look at the data in the database. You saw some examples of this in the previous lab where I had to use 2 select statements to get information from our database. And again, a lot of this should be reviewed from the previous course. In fact, I think most of this week is going to be kind of review of what you learned about previously as we level set to go into next week to get into some of the more advanced SQL that we have to understand for managing our databases. But basically with select, we list all of the columns that we want to select from a specific table where there's some kind of condition that's going to be met, and then we can group those conditions if we're doing aggregation or categorization, which I'll explain in a minute. And having is a where clause when we're using aggregation, which again, I'm going to show you here in just a minute. And finally, we can order the results so they're displayed in a certain way. So for example, let's say we want to find all the products that have a price that's less than $275. This is from your textbook, from the example database in your textbook. It's a furniture store, the example in the textbook. Out of these Pearson books for MIS, all use this furniture store example. But in that example, here we select 2 columns from the product table where the product standard price is less than $275. And that's just a simple operator. A comparison operator. And there's a bunch of comparison operators. Equal sign is equal to, greater than, then we have less than or equal, or greater than and equal to, less than and equal to, not equal to, which is the greater than and less than next to each other, less than and then greater than, and then not equal to, which is the exclamation point and then the equal sign. So those are our general operators that we can use in a where clause when we're creating conditions for the values of these columns. There's also the like operator, which I think I left out of this PowerPoint, but like lets you use a wildcard. It checks to see if the value is like something in our table, and I'll show you more of that in our hands-on section. So for example, By the way, alias is also kind of important because it makes it easier to work with your queries. So for example, here we have, we're selecting from our, uh, our customer address table, but instead of spelling out customer address every single time, I'm sorry, customer V table, instead of spelling out customer V every single time we're going to reference that table name, we can shorten it to cust by adding that alias. So if you look in the from part of that statement, it's the third line down, we put a space after the table name and then we put its alias. And then every time we reference that table, we put its alias dot column name instead of the full table name dot column name. So it makes it a little bit easier sometimes. A lot of times when I do this, I'm just putting one letter for the alias. You may have seen me do that in some of the examples because I don't want to keep typing out, um, a full table name. So I make it easier for myself just by using one letter, right? But you can run into some trouble with that if you're saving queries because then it's hard to decode what that query is doing if your aliases are not obvious. But also notice that the customer name is also aliased, right? So not only using the table alias within the customer name on that first line, we use the as keyword to declare an alias for the customer name so that when this, when we reference the customer name, we just need to use the value name. I will warn you that some database engines, while you can alias a column name, as is done here, they're referencing that alias in the where clause. Some database engines won't let you do that. Some of them you have to put the full name of the column in there. It only uses the alias in the results that it displays. It'll use the alias name. So just something to be aware of. I'm not sure why some database engines do that, but I've certainly used a few where I have to, if I try to do it like this, it doesn't work. I have to go back and change my where clause to use the real column names. And some of them are the opposite, where if you try to use the actual column name, it'll throw an error because it's expecting the alias, right? So sometimes you have to get to know your database engine when you're doing this type of stuff. Um, with select statements, there's also single row functions or aggregate functions. For example, count is a single row function, so it's going to count the number of records from a specific table, right? So here we're going to select the count from order line, where the order ID is 1004. So with aggregate functions, you can't have single valued columns included in the select clause unless they are included in the group by clause, right? So once you use a grouping function like this, so once I put count star, I can't select any other columns unless I add a group by that includes those columns, because you have to tell it how to group when you do aggregation. Otherwise, it doesn't know how to apply that aggregation to the other columns. And you'll see an example of that in my other video. So a select Boolean operators, so and, or, and not operators are for customizing conditions in the where clause, right? So here we have three different conditions in our where clause. The product description is like desk. That percent in the front, by the way, means that it's sort of like a regular expression. Our value has to end with the letters DESK, but whatever's in front of that can be anything. That's what the percent means. Likewise for product description, right? We're saying that the second line. So basically we're saying anything that is a desk or a table, and the price is greater than $300. So probably my intention behind this query is to see a list of all of the desks or tables that have a price over $300, right? That's the general idea here. Now here's the problem is that SQL is going to use the order of operations, right? If you remember from 5th grade math, please excuse my dear Aunt Sally, right? PEMDAS or whatever you used to call it. So SQL is going to use that order of operations if you don't give it a hint as to how you want it to process this query. So in this particular case, we're saying first we're looking at all desks or all tables, right? So the first thing it's going to do is find all the records that have desks or tables, and then it's going to add to that the products that have a standard price greater than 300. So really the first step is to process the and where the product description is like table and the standard price is greater than $300, right? So the only table records we're going to get are the ones that are over $300. That's that overlap that you see there. Then it's going to do an OR for all of the desks. So really what I'm going to get here in my result is all of my desks, and then I'm also going to get tables that are over $300. It's probably not what I want, right? I want everything under $300 that's a table or a desk. So in order to make that work, I could either change the way my where clause works, or what's a little bit easier is doing this parenthetically. You add the parentheses as a hint, right? So take a look at line 4 and 5 here. We added the parentheses around that or operator. So first, it should do what's in the right. So in PEMDAS, please excuse my dear Aunt Sally, parentheses came first. So first, it's going to process what's inside those parentheses. So in this example, we have first, it's going to find all desks and all tables that have a price over $300. So first, it's going to find our desks and tables. Then it's going to find everything over $300. So my results are going to be only those tables and desks that are over $300, which again is probably what I actually want, right? This is probably more in line with what we were looking for when we created this query. You can, once you get all these records, once you do a select statement, the database engine can display them or pass those records to an application sorted in a certain order. For example, let's say I want to sort the results by state and then by customer name, because I'm looking for customers in different states. Then I want to be able to look through by their name. So here I've got a SQL statement. By the way, this is another operator, the in operator. With the in operator, you can put a list of values, right? So at the in operator, I'm listing a bunch of values that I'm looking for with my database. So that's certainly another example. So in any case, because I have the order by clause here, it's going to only get those. It's going to first order them by customer state and then by customer name. With a group by, this is how we can select multiple columns when we're using aggregation, right? So you saw before when I did select count, I can only select one column, but here I'm selecting two columns. We've got the count by customer, we're counting the customer states, right? Which is really just going to count all the records, right? But then we're also going to display the counts by customer state. In other words, how many customers do I have in each state? That's basically what this is going to answer. And then we're going to group it by the customer state, which means, so then we're going to see a list of states and the counts for each one of those states, right? So the first column in our result is going to be the state. The second column is just going to be a number, probably an integer. That is the count of the number of records that contain all of the different values that we're looking for. So just give me a count of all my customers by state. All right, so, and here's another example. So we use the where clause to filter records for standard columns, but when we do aggregation with a function, we have to use the having clause. So in this case, we're only going to show records where there's more than one customer in that state, right? If there's only one customer in a state, they're going to be filtered out. This is going to show us where we have more than one customer in those states. So maybe if we only want to show the states that have lots of customers, we could do that. Or only states that only have a few customers, we could use less than. You can do this with money, right? Show me, the average where, it's greater than 50 or something like that, right? So you can do some interesting things with that. And you can use them together, right? You can have both a where clause to filter the records, and then from that filtered list, it will do the aggregation, which brings up an interesting question. If we're putting all of this stuff together, right? If we're combining all of these different clauses, what's the order that they're going to be parsed? So I want to show you what that looks like here. We always start with the from clause. So first, we take a look at the example on the left. We always start with the from, which identifies the tables. So the database engine is first going to say, okay, what tables is this person trying to look at? How am I going to filter this? That's the where clause. So let me filter first, right? So it's not going to do anything else. First, it's going to say, here's the tables I need, because it could be more than one table. We're going to talk about that next week. And then I'm going to find, the records that I need by filtering them. Then we're going to use our group by, right? So it's going to do its group by. So it's going to do the aggregation next, right? So the aggregation happens next. And then after the aggregation, it's going to do its the filtering by aggregation, right? So the having clause. Then it's going to get a list of columns that it has to display with the select clause, right? So the select clause says, here's the columns I want. So it's going to find just those columns. And then it's going to order those columns. It's going to put them in the right order. And then finally display the results or pass the results to an application. The important thing here that I want to talk about too is that the one exception to this is, this is from your textbook. And I think this is accurate for many cases, but if you do a top clause, right? So, imagine you've got billions of records. Look at our database that we imported from data.gov in our practical assignment. There's a lot of records, and we don't want to display all of those records all the time. We may want to paginate them or only show us certain, the top X number of records. So when you do a top clause, the filtering happens first. Then it's going to, from that filtering, from the where clause, it's then going to get the top X records, and then it's going to, I'm sorry, I got that backwards. After the order by, it's only going to return the X number, top X number of records from that result set. So there's one more box that has to be on the bottom here when we're doing when we're doing top or a limit, right? So in some database engines, it's a limit. In MySQL and MariaDB and Oracle, it's a limit. In Microsoft and Sybase, it's going to be top. So it's a little bit different syntax, but they do the same thing. We're just trying to return a finite number of records. So that's the basics. That's a nice little introduction to the select statements and again, a review of DML. So we learned about, DDL. So we did a review of DDL, very quick review, right? Showed you the syntax from our book, which is from SQL 2016 standard. And also I showed you select statements from the SQL 2016 standard. But again, we're going to probably do some other exercises together. They're going to show how to do this in MariaDB, which is going to be a little bit different than what we do in our from what the textbook shows us. And again, that's something we have to adapt to when we're working with any database engine. And that's it. Thank you for watching.